so if you need to go back and watch the video. So we're going to start out really basic with quadratics. We're going to let you just use your calculator because in the real world, you are going to be able to use calculator, so why not now? Okay, so here we go. Let's turn off the light. Okay, here we go. No. I'm always like this. Okay, it says, so we have to know, you guys have to know this vocabulary. When I say this, you have to know exactly what I'm talking about. So we're going to fill in, everybody, are you in the right spot? Yeah. We're going to fill this in. So we have this quadratic looking guy here, and you're going to fill in this dotted line. So look, a parabola is a nice U shape. Really important that you understand. Quadratics have a U, nice and round U shape. You've got to make sure to draw it nice and round down here at the bottom because there's a difference between a U and a V. There is V graphs, there's U graphs. So we're dealing with quadratics, which are U graphs. So this is called the axis of symmetry, which literally cuts our U into two equal pieces. If we stamp this across the dotted line, then it would be equivalent. So this is called the axis of symmetry. So if I say to you, find the axis of symmetry, what's the axis of symmetry? You would do the dotted line. Now we have to also be able to state this correctly. You see how it's at this x value of 1? Everybody? Yeah. Well, the y is changing. Look, this is y is 5, 4, 3, 2, 1, negative 1, 2. So y is changing, but x is always 1. This is over 1 up 3, over 1 up 4, over 1 up 5, over 1 up 6. So do you see how it's always at 1? Yeah. X is equal to 1. So our axis of symmetry will be x equals 1 in this parabola. Now where it crosses the x-axis are called our zeros or x-intercepts. Whatever you want to call them. You could see it called either zeros, x-intercepts, or when we solve the quadratic, what we're finding is where it crosses the x-axis. So they're also the solutions. Let's even add that in there. The solutions of our quadratic. They're called zeros, x-intercepts, or solutions. So we would write these for this type of problem. We would write at x equals negative 1. Isn't it crossing at x equals negative 1? And it's also crossing at x equals 3. That's how you can write it, or you can write it as a point. So isn't that going to this point, isn't that negative 1 up 0? Yeah. So you could write it like that, negative 1 up 0. And you could also write it over 3 up 0, xy. So pretty easy. Then this is called where it's crossing, so this is the y-axis, the x-axis. So right here where it's crossing the y-axis is our y-intercept. So if you have a graph, you have all the answers right there slapping you in the face. So our y-intercept would be, it's over 0 for x, but down 3. So we always write y-intercept as an xy point. Over 0 and then negative 3. Boom, boom. Sorry, I'll say that one more time. So we're going over 0, but we're going down 3, and boom, that's where it crosses. 0, negative 3. And then this is called the vertex. The vertex, which is always the lowest or highest point. So I can have a frowny-faced parabola, a frowny face, and that would be our max. And it's our vertex still, but it would be our max vertex. Everybody understand? And if we have a smiley face, then it's our vertex, but it's our min. So this is our vertex, and our vertex is at an xy point. Now let's figure out what xy point. Let's start at 0, 0. We're going over positive 1, down 4. So 1, negative 4 is our vertex, and it's a min value. So I want all of that information. Everybody understand? Okay, cool. So what you're going to do is go to the other parabola, and you're going to fill this in. You're going to tell me what's the y-intercept. We write it as a point. What's the x-intercepts? Write them as points. Do it exactly how we just did it on the front. Fill out your parabola. Ready, set, go. Couple notation things. So that when we get to the next part, it'll be easy for us. So if we have the graph of a quadratic, it's easy to say a few things. So our y-intercept would be 0 over 0, negative 3. Everybody seeing that? And then we've already done this. Our x-intercepts we would write as over -1 up 0. I'm just showing you. So you're just looking up here. We've already done this one. So our x-intercepts are -1, 0, and then over 3 up 0. Aren't the x-intercepts there and there, the zeros? So our vertex was at the point over 1, -4. Our axis of symmetry was at x equals 1. So this is how we're going to fill out our next parabolas in a minute. Our vertex is a min, and it's at over 1, -4, which we've already said. I just wrote it up there for some reason. Okay, our minimum was at that value, our vertex, which is 1, -4. Our domain, we have to be able to state domain. So everybody, this used to confuse people, but people always understand domain in my class for the most part. So domain, guys, domain means where is your function growing from left to right? Where is your function growing potentially from left to right? Well, isn't a parabola growing like this and this forever? Isn't it growing out this way forever? Yeah. Left? And to the right, it's growing this way. Now, domain has nothing to do with anything growing up or down. Nothing whatsoever. It's saying, where's my function growing from left to right only? Does everybody understand? So our domain for this one would be growing to -infinity, because over here on the x-axis, we keep walking this way forever. We're eventually going to approach -infinity. So, does everybody see how this is growing this way forever? Yeah. So -infinity, and it's growing this way forever. So it's going to be positive. So over here on the x-axis is -infinity, positive infinity. So our domain is from -infinity to positive infinity. Now our range is the opposite. Our range is the lowest y value, not y-intercept, on your graph, the lowest y value potentially to the highest y value potentially. So I'm going to switch colors here. What's the lowest y value? Not y-intercept, the lowest y value in general. -4, and then isn't it growing upwards to positive infinity up here? Yep, -4, so our range is -4 growing upwards to infinity. Now we do have to think about the range a little bit just because the range will get a bracket around -4 because doesn't it touch down right at -4? Everybody? And then here's the thing, why don't we put a bracket around infinity? Because infinity isn't a number, it's a place, I like to say. So it's not a number, it's a place. Infinity just means really, really large. It never ends. Does that make sense? It's not, you can't peg infinity as a number, it's just a place. Okay, now this is the next thing to note. It says, where is the function increasing? That means if you were literally walking on a hill, where would you be walking uphill? So let's look. Aren't I walking downhill right here? Yeah. From left to right, if we were to sit on this, we'd slide downwards. So we're decreasing. Now it's always for x values. Are we coming in hot from -infinity, sliding down the hill until we hit this x value at 1? Yeah. Does everybody understand? So we're decreasing. It says, where's the parabola decreasing? It's always x values. We're coming in hot from -infinity up to the x value of 1. Always putting parentheses around increasing and decreasing. Because at 1, we're just at the bottom of the hill. We're no longer increasing, no longer decreasing. Now after you hit the bottom of the hill, you're now at the bummer part where you have to walk back up the hill to ride down again. So now we're increasing, because look, if you were physically walking on it from left to right, you'd be walking uphill. So we're increasing from 1 to infinity. Please ask questions if I need to be a little bit more clearer on anything. So increasing and decreasing are always x values, never y values. So you might want to make note of that. Increasing and decreasing is always the x values where you're increasing and decreasing. Pretty easy. If you had a graph, it's like all the answers are just slapping you in the face. It's so easy. So we're going to use that information. Okay, awesome. So are you guys all done filling out your parabola, the second parabola? Okay, let's actually have you finish now the increasing and decreasing intervals for practice. Ready, go. So looking back up here, notice my highlighted line here. That's my axis of symmetry. Now, if you're a little butt guy sliding down a hill, you are decreasing, coming in hot from -infinity, right? Everybody. And you come in hot till you hit the wall at what x value, not the y value. It doesn't matter how far down you are for increasing and decreasing. We came in from -infinity till we smacked our face on the wall at 1. Then at 1, we then continue to have to walk uphill. As sweat is dripping off his forehead because that's a high walk. So then we are increasing from 1 to infinity for x. It's always x values. Okay, awesome. Here we go. Skipping this, we already know all this. Skipping that on your work. We already know all that. We've talked about it. We're good. So let's not BS. Let's just get right to it. So go to this problem, number 1. Here we go. Says, graph the quadratic, and then we're going to identify the axis of symmetry, the zero state, the max and min. Luckily for you guys, I'm okay with you using your graphing calculator to graph it. Just graph some XY points. So everybody, you'll go to your calculator. Everybody watch, because if you don't know how to use your calculator, you don't know how to make your life easier. I'm literally giving you, if you can graph it, and you can answer all these questions very easily. So go to your calculator. Oops. Right here, go to y equals. Everybody following me through this? Go to y equals. And then we've got to be able to type it in correctly. So is everybody in y equals? Yeah. The next thing you do is you've got to use negatives if it's a negative in front. But you've got to use minus signs if it's in between. So it's negative x squared. So you'll type in negative. Then right here's x. Squared. Now right here you can type in squared. Do you see this little cube? Squared. Everybody with me? Now the next part you can't type in negative 4x right down here. Negative 4x would be typed in wrong. You got to type in minus 4x and then it's minus 7. Now everybody hit graph. Oh. Right here. Right there. Where's the what? Right here, 2, x squared. So does everybody have this typed in almost? Now hit graph. We have to know how to use these calculators, and then once we know, it's the hardest part is just knowing how to use your calculator, and then it's easy from there. Hit graph. Do you see how I can't really see my parabola very good? We need to change my window. So let's change our window a little bit. In fact, you know what? We don't even need to. Who cares? Let's not worry about it. Now, instead of actually having the picture, we want exact points we can plot. So you'll hit the second key. Everybody with me? Hit second. And then graph, because we want the table of values. Do you see how it says table right up there? Do you see how I now have x, y points to plot? Okay, so what we're going to do is plot plenty of points. You have this up, so you're going to tell me some x, y points. So let me show you what you would write down on your paper. You would go off to the side and write x, y, and you're going to give me plenty of points. -3, and if we need to add in more, we can. -2, -1, 0, 1, 2, and then we'll see if that's enough points to draw in our parabola then. So what's -3 at? Look at your parabola. -4, what's -2 at? -3, what's -1 at? Very good. What's -7? -12? -19. So that's some pretty good points. Let's start plotting then. You have to plot the points correctly. So here we go. So we're going -3 down 4. Plot that point on your paper. I plotted that point. -2, -3. So -2, -3. Plotted that point. -1, -4. Okay, I've plotted that point. Over 0, -7. Over 0, -7. Cool. And then, do you see how after that, over 1 down 12 doesn't fit on my graph? Yeah. So we don't need to plot that one or that one because they don't fit. So, everybody, do you see the parabola happening? I can see it. Do you see the U? Yeah. It looks like it's coming up. I'm going to connect those points, but I've got to be exact. So, do you see how this must be my axis of symmetry? Right here. Can everyone see it, or do I need to explain further? So now let's draw in our axis of symmetry. Now we know that this parabola doesn't just stop, so won't this point be evenly over this point as well? Yeah. If we stacked it across, it's even. So look, from the axis of symmetry, it's over 1, 2. We have another point over 1, 2. So there's going to be that point right there. So now we can draw and finish drawing this in. Make sure you draw an arrow. See at the bottom of mine, I drew an arrow saying that it continues. So now we can answer all of our questions. I want you to answer. Identify the axis of symmetry. So you would say our axis of symmetry is x is equal to -2. Is everybody seeing it? Look.
Yeah.
Okay, so once we have a graph, we have all the answers. Identify the zeros. Is it ever crossing the x-axis? No. So there are no zeros. Does everybody understand? This is when we have imaginary solutions happen, which we'll do later. But do you see how it never crosses? So there are no zeros in this particular problem. And then it says state the max, state the min. So the max is, we do have a max. Isn't our max our highest point on the graph?
Yeah.
Our highest point on the graph is our vertex. So our vertex is our max, which is at -2, -3. So there's our max. There's no minimum. Isn't it going down to -infinity?
Yeah.
So there's no min. Now let's also state the domain and the range. The domain is where's my function growing from left to right. It has nothing to do with the fact that it's growing down. That does not matter for domain and range. Where's it growing from left to right? Isn't it growing this way forever?
Yeah.
And this way forever. Right? So our domain is -infinity to +infinity. And our range, we've got to look at our range though. Range is the lowest potential y value to the highest potential y value. So what's the lowest potential y value for this graph? Isn't it going down to -infinity? So won't that be the lowest y value?
Yeah.
So our range will be, our lowest y value is -infinity. And then what's our highest y value? Not y-intercept, y value. -3. So -infinity, and then -3 gets a parenthesis, a bracket, because it includes -3, meaning it stopped right at -3. Pretty easy stuff. If you have a graph, you have all the answers, not even having to do really much math. Yes. So one of us has typed it in wrong. Either whoever gave me the points typed it in wrong, or you have it typed in wrong. So just make sure you've typed it in right. Everybody go to your graphing calculator. Go to y equals with me. Let's see if those points are right. -2, -3. -2, yep, those points are right. So just make sure, my dear, that you have in y equals, you've typed in this exact thing. Okay. Okay, another one, example. Okay, let's do number 3 together, yes. You're just not typing it in. You're not typing X's and stuff, you're not making yes, okay, go to number 3, everybody. We're doing another example. Okay, here we go. So everybody go to number 6. I need you to all type it in right. So you have to go to y equals. And go up and let's clear that out. So it's x squared plus 6x plus 8, isn't it? Is it plus 8? Okay, cool. Now we're going to hit graph. Oh, look, there's my parabola. But we want the points, not the graph. We're drawing the graph. So second graph. So table, you're going to give me plenty of xy points. So you would draw an xy table. Plenty of points, maybe -3, -2, -1, 0, 1, 2. So what's -3 at? Quickly. And -2, -1, 0, 8, 1, 15, 2. Okay, we probably need some more points over on this side. I'm not really seeing what's happening, but we'll check it out. So we're going -3. Did everybody else get those same points?
Yeah.
Okay, -3, -1. There's a point. We have -2 of 0. We have -1 of 3. We have over 0 of 8. Over 0 of 8. Are we sure? This is number 3, isn't it? Yeah, it's number 3. Awesome. So now, do you see how I'm kind of like, well, what the heck's happening here? I have no idea. Aren't we plotting a lot of points on this side? We need to plot some more maybe on this side. So that means we need to go lower. Let's look at x, y. Let's go lower than -3. Maybe -5 and -4. So scroll up. You can scroll up on your arrows. What's -5 at?
-3.
And what's -4 at?
0.
Okay, that helps me. So I'm going -5, -3. Are you sure? Okay. That doesn't seem right. -4 up 0. No, something's going on. You've given me wrong points, people. It's -5 what? So -5 up 3. So we're going -5 up 1, 2, 3. There we go. And then we have, and it is over -4 at 0, right? Okay, now I can see my parabola, can't I? Okay, so now I can see it. There's my U. Make sure you don't just draw in, because look, I'm going to stop there. Now, can't I see my axis of symmetry must be right here? Because right there's my vertex, isn't it? Right? You can see it? So now look, this point will be stamped evenly across. So look, from the axis of symmetry, it's over 1, 2, 3. So from the axis of symmetry over 1, 2, 3, that's also a point on our graph. So now we can finish drawing this out. There's my parabola. Do we have any questions so far? We're almost done. So it says identify the axis of symmetry. It's at x equals -3. Look at it. Identify the zeros. So let's write them as x, y points. So our zeros are at -4 of 0. Everybody's seeing where zeros means where it crosses the x-axis, right? And then -2 of 0 is also a 0. Look, -2 of 0. Let's state our max. Well, look, it's going to positive infinity, so there's no max. But our min, it says state the min. Our min is our vertex. So our vertex is our min. And that's at the point -3, -1. So now we can do domain and range. Where's it growing from left to right? Forever, right? Left and right, isn't it growing -infinity to positive infinity, everyone? Because if this isn't making sense to you, this is the easy lesson. And our range is our lowest y potential value to our highest y potential value. Lowest y value is at -1, isn't it? And isn't it growing to positive infinity? And it includes -1. Can we all do this now on our own? Without any help? Okay, awesome. So finish the worksheet, check it out with me, do it at the end of the hour. You have 40 minutes.